So this is the overall content of this presentation. We will speak about internet and actually some security basics, and then the fundamental of DNS. And I'll show you a quick demo on how you can configure a recursive DNS server. And then we'll see what types of attacks which can be there on a DNS server, and what are the solutions which is available for DNS security. So I'll ask you first question. Question number one is, what do you mean by internet? You know that out of your 24 hours, minimum 2 hours everybody is spending on internet, right? Mobile phone. More than that, okay. You should know what you mean by internet. The same question I asked to my daughter. She's 7-year-old, and she replied like that: internet is this. I have my elder daughter, she's 10 years old. I shown some picture to her, and she told internet is not that, internet is this, where a lot of computers are connected and actually they are doing something. But internet is this. So how you can define internet now? Internet is what? It's a network, right? It's what? It's a network. No, it's not an only network. Then it is what? It's a network of networks, right? Internet is what? Network of networks. You have plenty of networks connected together. But again, that is not true. No. But internet is a network of networks which is globally accessible by end user, people like you. You can access it, then only it will be called internet. Right? So network of network which is globally accessible by the end user. This is called what we call an internet. Okay. Now we know about internet. So we have best thing of internet. What is this best thing? It says that everything is connected and it's a global network. Is it true? Yes, it is true. Because of this only you are able to do Facebook chatting, right? With your friend which is sitting in, say, Finland or Moisa. So the best thing is this. The same thing applies with the worst thing of internet. Everything is connected and it's a global network. Why? Because if you are connected, you have something called bad guy, hacker. He's also connected onto the internet. So he can actually get your data. Now, next question to you: what do you mean by security? According to two 10 years old boys, they're telling security is this. This is what we call it security, right? These are the security. Is it true? Okay, I told no, it's not security. I'm talking about computer security, right? Again, actually, the same question I asked my daughters. They are telling security is this. There, and we have security guard, right? Now, what is security as for you? How you can define a security? A computer security, more specific. You cannot define it. It's not a single process. It's a continuous process. For example, my laptop is secure. I can say I have a security feature there. For example, I have antivirus installed, right? I have a firewall running there. Then I cannot say it is secure. But tomorrow we have some vulnerability, some bugs in the software, right? And the hacker can use those bugs to get in my system. So it's a continuous process. I have to update my system regularly and all. So it's a continuous process. Security is what? Continuous process. So don't have any clear-cut definition of security. So we have three security features. If all features are it is satisfied, then you can say you are very much secure. Not 100%. You are very, very much secure. So property number one is called confidentiality. Now, what do you mean by confidentiality? For example, if I am sending an email to others, right? That email should not be read by anybody else. Only others should be able to read that email. So it's called confidentiality, right? Now, next is called integrity. Now, again, integrity means what? Others have sent in an email yesterday saying that you have a session tomorrow at, say, 11:30, right? Someone will say that tomorrow you have a session at 11:30 p.m. They will modify it, the mail, email, whatever he's sending, they are modifying it and sending to me. So they are modifying the integrity of the email, right? Modifying the integrity of the email. So it's again one more security feature. It's called integrity. No one should be able to modify the integrity of the software or any email or whatever. Again, final thing is called availability. Suppose you are browsing YouTube, you are watching some movie, Bahubali, right? And you feel that, okay, YouTube is not working, it is not available. And what will happen? It's not secure. It is not available at that point of time is what? It is not secure. So the service which is available to you should be able to access 24/7. Should be available. So this is what we call availability. So if these three security features are satisfying, then you can say you are pretty much secure, but not 100%. Nothing is 100% secure in this world. Now let us talk about DNS. Suppose you have a web browser, right? In the web browser, what you're doing, you're typing a URL. This is what you call as a URL. This is what you call as a URL, HTTPS, and then say www.cdac.in. Now, once you're typing this URL, what will happen? Your computer system will craft a packet, a network packet, right? So this is what is a network packet. So it follows a TCP/IP protocol, and a TCP/IP protocol says that you have something called application layer. Application layer means we have this particular protocol HTTP or HTTPS at the application layer, and we have this URL or this host name. This is what is application layer. Then what we have? Transport layer. In the transport layer, we say that this HTTP is working on TCP transport layer protocol, and it uses some source code and some destination code, either 18 or 443. It is a secure channel and it is using 443. Then comes network layer. So the system is crafting this packet. In the network layer, it says source IP. Now, what is your IP? What is the system's IP? That will write. And then it will write what is destination IP. This is the question mark. This is the big question mark. I don't know. This client doesn't know what is the destination IP of this CDAC.in. So here DNS comes in the picture. DNS will tell that if you want to know the destination IP, you give me the domain name and I will give you the destination IP. Right? You give me the domain name and then I will give you the destination IP. So DNS is what? DNS is a sub-service or an application in the internet which does what? Which will convert domain names to the IP addresses. So I have a domain name called www.cdac.in or www.msramayacollege.in, something like that. And then what is its IP address? It will give. So it will give both IPv4 as well as IPv6 addresses of a particular domain. And again, it can give the back also. Back means what? You are giving IP address to the DNS service and you want what is the domain name of that IP address. Right? This also will be given by the DNS. Again, DNS is the most critical component of today's internet infrastructure. How? Suppose DNS is not working, what will happen? Your email system will not work. You will not be able to browse YouTube. Not YouTube, nothing will you will not be able to browse anything through domain name. You will type the IP address of the YouTube or whatever you want to browse, right? That's why it's the most critical component of today's internet infrastructure. Again, DNS is a globally distributed. It's a globally distributed. So we don't have a single DNS server which is maintained by some organization. No. There are multiple DNS servers are there across the world which is maintained by different organizations. Again, it's a scalable. You can scale it. You can add new domains. If you want, you can add your own domain. Suppose we have a friend. What's your name, sir? You, yes. No, not yellow. Hi. Kushal.in. You want to own a domain called Kushal.in. So it's a scalable. You can add the domain also in the DNS and it will be available. Right? It's a more reliable database. So how this DNS is built, how it is built, it follows something called hierarchy, a tree structure. So on the top of hierarchy or tree, what we have is a root DNS server. This is what you call as a root DNS server. This is a root DNS server, right? So on the web browser where you are typing the URL www.cdac.in, it should be always ended with the root. These people are not typing. Browser is typing on behalf of us. So this is what you call as a rooted DNS server, right? Then what we have, top level domain, .in. So this is what you call as a top level domain. So we have two types of top level domain. One is a generic top level domain like .com, .org, .edu and all. And then second is country code top level domain like .in, .pk, .us, .uk, .fn and all. So this is what you call a top level domain. Then in the hierarchy, next level what we have is CDAC.in. It's a second top level domain. which is called second top level domain, and so on. So this is what you call is a host inside this hierarchy. So you can see this hierarchy is being followed like this. So if you're typing www.cdac.in, you have a root, you have a top level domain, you have second top level domain, then what you have? A host name, right? So this is how the DNS is there. Now let us see how this DNS works. How this DNS works. Suppose I am typing a URL on this laptop. This laptop is connected to Wi-Fi, which is given by MS server. And then on this laptop, I am typing www.cdac.in. This URL I am typing on this laptop, on the web browser. Now what happened? As I told you earlier, it will craft a packet. In that, I have to mention the destination IP address, right? The destination IP address we don't know, so we will send one DNS query to one local DNS server. So this organization is maintaining a DNS server, a local DNS server. It is called recursive DNS server, right? So one query will be sent to local DNS server. Now this local DNS server will give you the answer. Answer is what? It will say that, okay, you are asking for www.cdac.in, whether I have IP address for this domain name or not. Now, local DNS server will have something called DNS cache. Cache is what? Already previously some clients, they requested for something, it's been cached with me, right? Suppose this cache is empty, nothing is there in the cache, or this entry for www.cdac.in is not there in the cache. Now what will happen? This local DNS server is having internet accessibility, right? What it will do, it will send a query to a root DNS server. As I told, it is a hierarchical structure. On the top of hierarchy, what we have? A root DNS server. So a query will be sent from local DNS server to root DNS server saying that I want to know the IP address for www.cdac.in. You please give me. Now, root DNS server, as you see in our this hierarchy, it will hold the information about top level domains. It will hold the information about the top level domains. The root will hold information about only top level domains. That's all. What are the IP address of the top level domain? So we are asking for www.cdac.in to root, but root will reply back saying that I don't know the URL which you're asking, what is the IP address of that URL, www.cdac.in, but I can give you the IP address of top level domain, which is .in, which was part of that URL, right? Which was part of that URL. So I have not got the answer. This local DNS server has not received the answer, but it has got some referral. Whom to ask now? Next. Again, my DNS server will ask to this TAD.in, right? Tell me the IP address of www.cdac.in. Again, this the .in TAD will contain what? If you see, this TAD will contain the information about, this is TAD, right? These are the TAD. These are TAD will be contain the information about second top level domain. This is called CDAC.in or AC.in or something like that. So they will again reply back saying that I don't know about the www.cdac.in, but I know the guy whom you can go and ask. That guy is CDAC.in, right? So you please go and ask to CDAC.in. So this reply will come from TAD to our recursive server or DNS server or local DNS server saying that you please go and ask to STAD, which is called CDAC.in, and this is the IP address of STAD. Again, this local DNS server will ask to STAD saying that please give me the IP address for www.cdac.in. Now this STAD will hold the data of the host which is part of the domain, right? So here we have the information of www.cdac.in. So the IP address will be taken from the database of the CDAC.in STAD and it will be given back to the recursive server, or it is called local DNS server. Once we get the IP address to this local DNS server, now what will happen? This local DNS server will cache the IP address what we have received for the domain name into the cache, its own cache, and the same will be given back to the client. Now, once the client knows the IP address, it will craft the packet and it will do the communication. So this is how the DNS works, right? This is the process of DNS, how it works. Okay, so let us see what type of DNS servers are available. Classifications of DNS servers. So in that process, we have seen that we have a DNS client, we have a local DNS server, which is called here as a recursive server. Then we have a root DNS server, and these servers are called authoritative DNS servers. They are authoritative to give the output of some or give result of some domain, right? So we have these many DNS servers, root DNS servers, right? And then authoritative DNS servers, which can be master or slave. Master is what? If slave is down, if master is down, slave will take care, right? So two servers are running. If one is down, other one takes care. Then we have a recursive DNS server, which you have seen. And stub resolver is nothing. Your DNS client, my laptop, is always called as a stub resolver. Okay, so as we know, the root DNS server on the top of hierarchy is there. Oh, it contains what? It contains the information about the top level domain. For example, .in, .org, .com, .gov. So we don't have a single root name server. We have multiple root name servers, right? And again, those root name servers are spread across the world. It is there in India also. So there are actually 13 root DNS servers. Root DNS servers, we have 13 across the world. And again, those 13 also have some mirrors. Copy of those 13 is available everywhere. So in India, we have a copy, and these root name servers actually are named from A, B, C, D up to L. Up to L, right? And you can see in India, we are having the root name server D, E, F, I, J, K, L, mirror of that what we are having here in India. And even in Bangalore, we are having actually F and K. These two are there in Bangalore. So these are the organization who is maintaining the root DNS servers. And they are giving it free of cost. They are maintaining it free of cost. They are not charging money from anywhere. Free of cost they are giving. Now, as I told, we have A, B, up to M actually. Sorry, we have 13 up to M. What we have, and all are actually you can see from US organizations. Most of them. Only two are there from which is from Japan and UK, and one. This is SC means Sweden. SC some country. So we know about root DNS server. On the hierarchy on top, what we have root. Then what we have authoritative. Authoritative means what? The DNS server who will give actual reply of the domain name which you are asking for. For example, we have authoritative DNS server called CDAC.in who was giving answer for www.cdac.in. And recursive server is nothing. Your local DNS server is called recursive DNS server. And you should know one thing. This local DNS server is maintaining or caching or logging all your queries. Means what? What you are browsing will be stored there in the local DNS server. So what you are browsing, your name I forgot. Kushal, what he is browsing will be stored in the the local DNS server. So what are you browsing will be stored, right? So what I mean to say here, you can create your own DNS server and you can use it so that those data cannot be revealed. Your information cannot be stored in any other DNS server. You can use your own DNS server. I'll tell you how to configure your own DNS server. And I told you stub resolver is what your DNS client is called a stub resolver. Now we have various query types, different query types. Number one is iterative query. So we have already taken the example of iterative query. Client is contacting to local DNS server for some for asking IP address of some domain name. Now this local DNS server will send a query to root. This is iterative query. Local DNS server will send a query to root. Root will reply back. This is one iteration, right? Again, local DNS server will send query to top level domain. It will reply back. The second iteration. Again, third iteration, and fourth, and so on. So this query is called iterative query. And nowadays we are only using iterative query. We are no more using recursive query. Now, what do you mean by recursive query? I'll tell you next slide. This is what a typical example of recursive query. Yes.
This local server DNS server is located at the local application.
Yes.
Other servers where it will located.
That's what root DNS server is located across the world. In India also we have two, not two. In Bangalore we have two. India we have 7, right? And suppose CDAC.in is maintained by CDAC people, the organization. In is maintained by NIXI. NIXI is an organization who is maintaining the DNS server.
What is the basic difference between the local DNS server and the CDAC.in DNS server? CDAC is also maintaining the same server?
CDAC.in, who will give the answer about www.cdac.in? Who will give the answer? Local cannot give the answer. Local will ask to www.cdac.in, and cdac.in will give the answer. Right? So I guess MS Ramaya College also is maintaining some DNS server, and that is again it's authoritative DNS server for their own domain. So I was talking about identity query. Now what we have is recursive query. This is a typical example of recursive query. Again, client is sending a query to a local DNS server. Local DNS server will forward the query, and root will hold that query. Now, root will not reply immediately here. In recursive query, root will hold that query, and root will ask to TLD on behalf of this local DNS server, and so on. So this is called recursive query. But recursive queries are very dangerous. Earlier it was available, now it has been stopped at root and at TLD. But authoritative servers still they have recursive query. Right? You give me some time, huh? I know you are feeling hungry. So this configuration I will do it later at the end actually. So for that I am having a CentOS virtual machine. Configuration is what? I will show you how you can set up your own DNS server. It's a recursive DNS server, so that people cannot see what you're browsing. People cannot see, right? So that I'll teach you later. Let us talk about security of DNS, the attacks which can happen on DNS server. So there are 2 types of attack. Attack onto DNS server and attack to others using DNS servers. Right? So 2 types of attacks are there. Attacks directly on DNS server, and second is attacks on other server, other infrastructure using DNS server. So we'll see attacks onto DNS infrastructure. So there are plenty of attacks which can happen to DNS servers. So I will just discuss a few of them. I will discuss this. This is called man in the middle. I guess our Mohit sir from Finland, he already spoke about this. Let us see what we mean by man in the middle attack. Now, I again forgot your name. Tushar, huh? I am not forgetting now. Tushar is using his mobile phone, right? And Tushar is browsing a website called Facebook.com. So if he is browsing, he will craft a packet. In that, he has to write what is the destination IP address, right? Now, for that, he is sending his system will send a query to local DNS server. The query will be sent to local DNS server here. Now, local DNS server will do something and all, but in between, I will reply on behalf of the local DNS server to Tushar, saying that you wanted to know the IP address for www.facebook.com. This is the IP address, and this is a fake IP address, not real. It is not facebook.com IP address. It is something else, right? Now, I am replying on behalf of that DNS server. So it is called man in the middle. This can be easily done in the LAN. LAN environment, it can be very easily done. Through EtherCap, we have so many tools you can use it for doing that kind of thing. Once he will get the IP address, now he will go to some wrong website, not Facebook.com. If he will type his IP address, means that Facebook.com, he will get CDAC.in webpage, right? So this is very common attack which can happen in the network. It's called man in the middle attack. Now one more attack is there onto DNS server. It's called DOS, denial of service. What it says that I am sending a lot of queries to a local DNS server, so that the legitimate user they cannot query to that. Right? I give a heavy load to the DNS server saying that you please resolve some queries and keep giving you a work. He will be busy doing those work, but when legitimate user they will send, they will reject that query. I will not respond to you because I am busy doing some other work. Right? So denial of service. This service will be denied by the attacker, so that normal user cannot access your DNS server. This can happen. UDP flood you do, TCP flood you do. Plenty of attacks are available. Then we have one more, better than DOS. It is called DDoS, distributed denial of service. Now earlier, only attacker is sending one query or plenty of query to the DNS server. Now here, plenty of other systems also will send or bombard the queries to the DNS server. So it's called distributed denial of service. So we have plenty of systems which is actually sending queries to this server, and this server actually the full network will be used to utilize, and then legitimate user cannot get it. It's called distributed denial of service. Now let us talk about some attack on to other system using DNS infrastructure. Using DNS infrastructure, you can attack others also. So we have plenty of attacks: DNS reflection, DNS amplification, DNS tunneling, and hijacking. We'll see one by one. This is called DNS reflection. Now, what do you mean by DNS reflection? I am sending a query to Tushar. Tushar is what? DNS server. Sorry, what's the name? Again, Kushagra. Well, very good, very good. Now it says Kushagra, right? Okay, I am sending a query to Kushagra, saying that I am Adarsh. Sorry, not that. I am Adarsh, right? When a query will go to Kushagra will give reply to Adarsh. Sorry, correct, Kushagra. Kushagra will give reply to Adarsh, right? So it's called reflection. It's called reflection. I am sending a query to Kushagra is going to give reply to Adarsh. So it's called reflection. So I am spoofing the IP address of victim and sending a query to DNS server. DNS server will reply back to the victim. So unnecessarily, victim is getting the DNS reply. Unnecessary. He has not asked for something, but he is getting some traffic. Right? This can be amplified also. Amplified means what? I will send to this DNS server saying that I want all the domains or subdomains, like google.com has how many subdomains? Can you name? We have gmail.com, we have translate.google.com, maps.google.com. Huh? Or can YouTube? No, YouTube is different. Like that, we have plenty of subdomains. So I say that you give me the reply of all the other domains also, all the records. So if I send only one query, I get multiple responses. So it is amplified. Your actually attack is being amplified. So I send one query to Kushagra. Kushagra will give multiple replies to others. Unnecessary, others is getting traffic. Unnecessary. So this is very common attack. Anybody can do this kind of attack. It's called reflection and amplification. Okay. Then we have very important attack. I guess you know this. All of you know this? Yes. Yes. People are saying yes. Most of the students, they know this. Because here, suppose MS Ramaya College says that we will not give internet access to students. We have timings. Right? We have timings. But still they will get internet access because of this DNS tunneling attack. If you are not doing that, then you are nowhere actually. Are you doing or not? Most of the colleges, they are doing this. The students, they are doing this kind of DNS tunneling. Using DNS tunneling, you can browse internet on the system. So this system is not having internet access. And he has to browse internet. Now what he will do, he will bypass the firewall using DNS tunneling and can browse internet through attacker's machine. So the firewall already something is mentioned that students cannot browse internet. But still, student will be able to browse internet through DNS tunneling attack. So they will create a tunnel and they will go to the attacker machine. Attacker machine will actually browse internet on behalf of this. So this is very common attack. I don't think I thought you were doing, but okay, leave it. Then one more attack is there. It's called DNS hijacking. It's called DNS hijacking. Suppose Kushagra is having one laptop. Kushagra is having one laptop. On Kushagra system in the laptop, I am changing the TCP/IP setting and changing the DNS entry to the my DNS server, rogue DNS server, a fake DNS server. And once DNS query to fake DNS server, I will give the fake website to him. The IP address of fake website I will give to him. Right? So it is called DNS hijacking. So in 2008, we had this Huawei-3Com router, not router, but broadband routers. There, this kind of attack was happening by Chinese people. They modified the TCP/IP settings of their routers, and the China people, they are spying India's data, what actually we are browsing on, everything they are spying. So again, this is a very common attack. Now, how to secure yourself from these kind of attacks? That is next question. How to secure yourself? We have plenty of security solutions. Number one is that DNSSEC. DNSSEC is well implemented. It is in use, but DNSSEC cannot protect from these kind of attacks. What we are talking these attacks we cannot protect, but we can protect DNSSEC from only MITM. DNSSEC can be protect from this kind of attack, but it cannot protect from DOS, DDoS, and reflection and nothing, right? And we have one more security solution called TSIG, transaction signature. It is actually for master and slave only. Secure communication between master server and slave server. So you have to have something called TSIG, transaction signature. And we have some firewalls also, DNS firewalls. They claim that they are protecting from all the attacks what I have shown you, but they are actually not doing. They are not doing. And I am actually working on these two solutions. Number one is DNS health measurement. Number two is DNS intrusion detection. Now, what is this DNS health measurement? Sitting on my system, I can measure the health of any DNS server in the world, whether that DNS server is healthy or under attack. Right? This is what we are doing. And then we have something called DNS intrusion detection. It's again, it's kind of firewall, but it's not firewall. It will detect the intrusion which is happening in the DNS servers. So there we have created some signatures for application attack, for tunneling attack, for reflection attack, and for hijacking attack. So this is what we have done. So this I have talked. Do we have time now? 5 minutes. Okay. So in that 5 minutes, I show you a quick demo how you can set up your own DNS server. Kushagar, right? Kushagar. So what I'm doing, I'm having this Linux machine with me. It's a Linux virtual machine, CentOS. You know about CentOS? It's operating system. Okay. So this CentOS, I will install recursive DNS server, means local ISP DNS server. So how to do that? There is only one command. Yum install. You say yum install bind. Bind is a software for DNS server. Bind is what? It's a software for DNS server. So say yum install bind and say enter. So here actually I don't have internet access on this VM. Otherwise it will contact to the internet repository of CentOS and it will download that bind and it will install. For me, it's already installed. So once this is installed, second is you have to configure your bind. So for configuration, you say open this configuration file. This is the main configuration file, named.com. It's a main configuration file for bind DNS server. So if you open that file, here only two changes you do. Number one change is listen on port number 53. Yes, DNS will use UDP port number 53 for querying and responses. So we'll say listen port number 53 and you type your IP address. The IP address of this system is CentOS. So suppose the IP address of the CentOS is say 192.168.1. Say some IP address I'm giving. I don't have internet access, that's why I'm giving some IP address. Type that IP address. And second change, what you do is you say allow query. Allow query from all. Anybody can query to your DNS server. You say allow query from. You say any. Allow query from any. That's all. These two changes you do, and then save your file. So I'm using VI editor. You know how to save changes in VI editor. You can use any other editor actually. Now this is saved. After this, you start the service. DNS service has to be started. So here we have one command systemctl and then say start and say main B. Main B is a DNS service here under bind. Say enter, it will be started. So once this is started, now you go to your system. And now you use that DNS server what you made. You say open network settings center. change adapter setting, and here we have Wi-Fi settings. Under that, I write my DNS server here. So use following DNS server. I write my DNS server. What is the IP address? 192.168.1.8, something I will write. If I do that, now my queries will go to that DNS server which I have configured. Nobody can now spy on me. Nobody can see what actually I am browsing. Even our ISP also cannot see what I am browsing. Right? They can see packets which is going and coming, but they cannot see what website actually I am browsing. Right? So this is how you can configure this DNS server. I guess I am through. Any queries, questions? Tushar? Any question? No question. So you people are feeling hungry? Thank you.